Very good morning, friends. Today we'll continue lecture number 4 on differential equation topic. In this lecture, we'll be doing linear differential equation. See, when variable separable is not possible, then we have to go for substitution. One was simple substitution, which you can make out very easily, such as dy by dx is equal to cos x plus y. Then you can replace x plus y as what? V, and then find out dv by dx. And then we can separate variable. Second time is what? Homogeneous differential equation. That also we have done. There we have to substitute y is equal to vx. And next type is what? Linear differential equation. When variable separable is not possible, then we can go for linear differential equation. So let us begin. Linear differential equation. What is linear differential equation? A differential equation of the type dy by dx plus py is equal to q, where p and q are either constant or functions of x only are known as linear differential equation. In this case, we will multiply both sides by integrating factor. Where if is what? E raised to integral t dx. Second type, a differential equation of the type dx by dy plus px is equal to q, where p and q are either constant or functions of y only is known as linear differential equation in y. is known as linear differential equation in X, in Y. In this case, multiply both the sides by integrating factor, where integrating factor is what? E raised to integral P dy. Let us solve some problems. Dy by dx plus y upon x. Solve the following differential equation. First one is dy by dx plus y by x is equal to x cube minus 3. This is equation number 1. Is linear differential equation in X. Here P is what? 1 upon X, and Q is what? X cube minus 3. Both are functions of X. Therefore, integrating factor is what? E raised to integral P dx. E raised to integral 1 upon X. E raised to log X, which is nothing but X. Multiplying equation 1 by so X dy by dx plus y is equal to x raised to 4 minus 3x. Now, when we'll multiply by integrating factor, then left hand side will be derivative of something. It is d by dx of x into y is equal to x raised to 4 minus 3x. By definition of integration, xy is what? Integral x raised to 4 minus 3x plus dx plus c. X raised to 5 upon 5 minus 3x square by 2 plus c is required general solution. Second is cos square x dy by dx. Plus y is equal to tan x. We will divide by cos square x. So dy by dx plus 1 upon cos square x is equal to tan x upon dy by dx plus sec square x y tan x. Write this as equation number 1. Is linear differential equation in x. Here P is what? Sec square x and Q is what? Sec square x tan x. Therefore, integrating factor is what? E raised to integral P dx. E raised to integral sec square x dx. Which is e raised to tan x. Multiply equation 1 by e raised to tan x. E raised to tan x dy by dx plus e raised to tan x sec square x into y is equal to e raised to tan x sec square x into tan x. Now left hand side is what? It is d by dx of one is e raised to tan x, second is y. Into y is equal to e raised to tan x into sec square x into tan x by definition of integration. Derivative of this is that. The integration of this will become this function. So e raised to tan x into y is what? E raised to tan x sec square x into tan x. Dx plus c. Therefore, y e raised to tan x will take tan x as t. Its derivative is what? Sec square x dx. Tan x is t. Its derivative is what? Sec square x dx is what? dg. So this is what? T e raised to t dt. T is tan x. So y e raised to tan x e raised to t into bracket t minus 1 are Pising's identity. Y e raised to tan x is equal to e raised to tan x in bracket tan x minus 1 plus c. We can divide by e raised to tan x. So y will be what? Tan x minus 1 plus c upon e raised to tan x will give you what? C e raised to minus tan x is general solution of given differential equation. See third one. X plus 2y cube dy by dx is equal to y. X plus 2y cube dy by dx is equal to y. See, in this case, if we divide this by here, left hand side, then we cannot convert to linear differential equation. So what we have to do, we'll keep x plus 2y cube on left hand side only is equal to y into dx by dy. So dx by dy is what? This y you divide. So x upon y plus 2y square. Therefore dx by dy minus x upon y is linear differential equation in y. Here p is what? Minus 1 upon y and q is what? 2y square. Integrating factor is what? E raised to integral p dy minus 1 upon y dy e raised to minus log y e raised to log y raised to minus 1 will give y raised to minus 1 is equal to 1 upon y. Multiplying equation 1 by 1 upon y. Multiplying equation 1 by 1 upon y. So 1 upon y dx by dy minus x by y square is equal to 2y. Now this left hand side is what? D by dx of d by dy of 1 upon y into x is equal to 2y. By definition of integration, x upon y is what? 2 times integral y dy plus c. So x upon y is what? 2 into y square by 2 plus c. So x is equal to y cube plus cy is required general solution. C fourth. Dy by dx plus y sec x is equal to tan x. Is linear differential equation in x. Here p is what? Sec x and q is what? Tan x. So integrating factor is what? A is to integral p dx. A is to integral sec x dx. A is to log sec x plus tan x will give you sec x plus tan x. Multiplying equation 1 by sec x plus tan x. So we'll give you what? Sec x plus tan x into dy by dx plus sec x into sec x plus tan x into y. Is equal to sec x plus tan x into tan x. Tan x. Now left hand side is what? D by dx of sec x plus tan x into y is equal to sec tan plus tan square x. By definition of integration, derivative of this is this. So integration of this will be this function. Sec x plus tan x into y is integral sec x tan x plus tan square x dx plus c. Therefore, y into bracket sec x plus tan x integral sec x tan x plus tan square can be written as sec square minus 1. dx plus c. So y into sec x plus tan x. Integration of sec tan is what? Sec. Integral sec square is what? Tan x minus x plus c is general solution of given differential equation. Fifth is x dy by dx plus 2y is equal to x square log x. Now first divide by x. Dy by dx plus 2 upon x y is equal to x log x is linear differential equation in x. Here p is what? 2 upon x and q is what? X log x. Integrating factor is what? E raised to until p dx. 2 upon x dx. E raised to 2 log x. E raised to log x square. Will give you x square. Multiplying equation 1 by x square. So x square dy by dx plus 2x y is equal to x cube log x. Left hand side is what? D by dx of x square y is equal to x cube log x. By definition of integration, x square y is what? Integral x cube log x dx plus c log x integral x cube dx minus an integral derivative of log x into integral x cube dx the whole dx plus c. X square y is what? X raised to 4 log x upon 4 minus 1 upon x into so x square y is what? X raised to 4 log x upon 4 minus 1 by 4 integral x cube dx plus c. X square y x raised to 4 log x upon 4 minus x raised to 4 by 4 x raised to 4 by 4 you can take common. In bracket we'll get log x minus 1 by 4 plus c is required general solution. So 6 x plus y dy by dx is equal to 1. In this case, if you transfer 1 upon x plus y on that side, then we cannot convert to linear differential equation. So what we have to do, we'll keep x plus y on this side, transfer dx by dy. That is dx by dy minus x is equal to y is linear differential equation in y. Here p is what? Minus 1 and q is what? Y. So integrating factor is what? E raised to integral p dx, p dy minus 1 dy. Multiplying equation 1 by e raised to minus y will give you what? E raised to minus y dx by dy minus x e raised to minus y is equal to y e raised to minus y. Left hand side is what? D by dy of e raised to minus y into x. By definition of integration, x e raised to minus y is what? Integral y e raised to minus y dy plus c. X e raised to minus y integral e raised to minus y dy minus d by dy of y into integral e raised to minus y dy, the whole dy plus c. So x e raised to minus y is equal to y e raised to minus y upon minus 1. Derivative of y1 e raised to minus y upon plus c. X e raised to minus y is equal to minus y plus integral e raised to minus y dy. X plus y e raised to minus y is equal to e raised to minus y upon plus c. Divided by e raised to minus y, so x plus y is equal to minus 1 plus c e raised to plus 1. You can bring 1 on this side. Is required. General solution. Seventh is x plus a dy by dx minus 3y is equal to x plus a raised to 5. We'll divide by x plus a. So dy by dx is what? Minus 3 upon x plus a x plus a raised to 4 is linear differential equation in x. Here t is what? Minus 3 upon x plus a, and q is what? X plus a raised to 4. Integrating factor is what? E raised to integral p dx. E raised to integral minus 3 upon x plus a dx minus 3 log e raised to log x plus a raised to minus 3 will give you x plus a raised to minus 3. Multiplying equation 1 by one upon x plus a cube, x plus a raised to minus 3 is 1 upon x plus a. 1 upon x plus a cube into dy by dx minus 3 upon x plus a raised to 4 into y is equal to x plus a. Left hand side is what? d by dx of 1 upon x plus a cube into y, which is same as x plus a. By definition of integration, y upon x plus a raised to 3 is equal to integral x plus a dx plus c. So y upon x plus a raised to 3 is equal to x plus a square by 2 plus c. X plus a raised to 3 you multiply. Y is equal to x plus a raised to 5 1 upon 2 you write plus c into x plus a raised to 3 is general solution of given linear differential equation. Eighth one is y dx plus x minus y square dy is equal to 0. Therefore, y dx by dy plus x minus y square is equal to 0. Divide by y. So dx by dy plus 1 upon y into x minus y you transfer on that side is linear differential equation in y. Here p is what? 1 upon y and q is what? Y. Integrating factor is what? E raised to p dy. E raised to 1 upon y. E raised to log y, which is y. Multiplying equation 1 by y. Y we get y dx by dy plus x. Left hand side is what? D by dy of y into x. By definition of integration, derivative of this with respect to y is this. So integration of this with respect to y will be this function. So yx is what? Integral of y square dy plus c. xy is what? Y cube by 3 plus c is required general solution. Ninth is dr plus 2r cot theta plus sin 2 theta d theta is equal to 0. So dr by d theta plus 2r cot theta plus sin 2 theta dr by d theta plus 2 cot theta into r is equal to minus sine 2 theta. Write this as equation number 1 is linear differential equation in theta. Here P is what? 2 cot theta and Q is minus sine 2 theta. So integrating factor is what? E is to P d theta e is to 2 cot theta d theta e is to 2 log sine theta e is to log sine square theta will give you sine square theta. Multiplying equation 1 by sine square theta. So we'll give you sine square theta dr by d theta plus 2 cot theta into sine square theta r is equal to minus sine square theta sine 2 theta. Sine square theta into dr by d theta. Now, cot is what? Cos of one sine. One sine will get cancelled. Will give you what? 2 cos sine. 2 cos sine is what? Sine 2 theta. Into r is equal to 2 sine 2 theta is what? 2 sine theta cos theta. So 2 sine cube theta cos theta. Left hand side is what? D by d theta of sine square theta into r is equal to minus 2 sine cube theta cos theta. By definition of integration r into sine square theta is what? Minus 2 integral sine cube theta cos theta d theta plus c. Put t is equal to sine theta. So dt is what? Cos theta d theta. So r sine square theta minus 2 into t cube dt plus c. T raised to 4 upon 4 plus c. R sine square theta is what? Minus 1 by 2 sine raised to 4 theta plus c, because t is what? Sine. Is required General solution. C10 1 minus x square dy by dx. Dy by dx plus 2xy is equal to x into 1 minus x square raised to half. Root 1 minus x square. Now first we'll divide by 1 minus x square. So dy by dx plus 2x upon 1 minus x square into y is equal to x root 1 minus x square upon, therefore dy by dx plus 2x upon x upon root is linear differential equation in x. Here p is what? 2x upon 1 minus x square. And q is what? X upon root 1 minus x square. So integrating factor is what? E raised to integral p dx. Two x upon 1 minus e raised to minus 2x upon numerator is what? Derivative of denominator d by dx of 1 minus x square upon 1 minus x square, which is equal to e raised to minus log this is integrating factor. Multiplying equation 1 by 1 upon 1 minus x square. So 1 upon 1 minus x square dy by dx plus 2x upon 1 minus x square the whole square into y is equal to x upon 1 minus x square raised to 3 by 2. Left hand side is what? D by dx of 1 upon 1 minus x square into y. Three by definition of integration, y upon 1 minus x square is equal to integral x upon 1 minus x square raised to 3 by 2 dx plus c. Put t is equal to 1 minus x square. So dt will be what? Minus 2x dx. So dt upon minus 2 is what? X dx. So y upon 1 minus x square is equal to minus dt upon 2 divided by t raised to 3 by 2 plus c. Minus 1 by 2 t raised to minus 3 by 2. Integration of t raised to minus 3 by 2 is what? Minus 3 by 2 plus 1. Minus 1 by 2 upon minus 1 by 2. Y upon 1 minus x square plus c. Half will get cancelled. Y upon is equal to 1 upon root t is 1 minus x square. Multiply followed by 1 minus x square. So y will be what? The p into is required. General solution. C11 1 plus x square dy by dx. Plus y is equal to e raised to sine inverse x. E raised to tan inverse x. Dy by dx plus 1 upon 1 plus x square into y e raised to tan inverse x upon is linear differential equation in x. Here p is what? 1 upon 1 plus x square and q is what? E raised to tan inverse x upon 1 plus x square. Saying that. So in this case, integrating factor is e raised to integral p dx. 1 upon 1 plus e raised to tan inverse x. Multiplying equation 1 by e raised to tan inverse x e raised to tan inverse x dy by dx is equal to a plus e raised to tan inverse x upon 1 plus x square into y is equal to e raised to tan inverse x into e raised to tan inverse x will give you what? 2 tan inverse x upon 1 plus x square. So left hand side is what? D by dx of e raised to tan inverse x into y. E raised to 2 tan inverse x upon so by definition of integration y e raised to tan inverse x is equal to e raised to 2 tan inverse x upon put t is equal to tan inverse x. So dt is what? So y e raised to tan inverse x is equal to e raised to 2t dt plus c. 2t upon 2 e raised to 2 tan inverse x we can divide by e raised to tan inverse x. So y will be e raised to tan inverse x upon 2 plus c e raised to minus tan inverse x is required general solution. Which passes through origin and has slope x plus 3y x plus 3y minus 1 at any point xy on it. Let equation of curve be y is equal to fx. Slope of curve, or you can say tangent, is equal to dy by dx. So dy by dx is what? X plus 3y minus 1. Therefore, dy by dx minus 3y is equal to x minus 1 is linear differential equation in x. Here, p is minus 3 and q is x minus 1. Integrating factor is what? E raised to integral p dx. E raised to integral minus 3 dx. E raised to minus 3x. Multiplying equation 1 by so e raised to minus 3x dy by dx minus 3 e raised to minus 3xy is equal to x minus 1 e raised to minus 3x. Left hand side is what? D by dx of e raised to minus 3x into y is equal to x minus 1 into by definition of integration y e raised to minus 3x integral x minus 1 into integration by parts. So x minus 1 integral e raised to minus 3x minus an integral derivative of x minus 1 integral e raised to minus 3x dx the whole dx plus c y e raised to minus 3x x minus 1 e raised to minus 3x upon minus 3 minus 1 into so y e raised to minus 3x is equal to 1 minus x upon 3 plus 1 by 3. Again, integral e raised to minus 3x is what? E raised to minus 3x divided by e raised to minus 3x will give you what? Y is equal to 1 minus x upon 3 minus 1 by 9 plus c e raised to 3x. Equation number 2. Since curve passes through O00, therefore 0 is equal to 1 minus 0.3 minus 1 by 9 plus c into e raised to 0 is 1. So 1 by 3 minus 1 by 9 will be 3 minus 1, 2 by 9. Minus 2 by 9. Substituting c in equation 2. Substitute in equation 2. Y is equal to 1 minus x upon 3 minus 1 by 9 minus 2 by 9 e raised to 9 you can multiply. So 9y is equal to 3 minus 3x minus 1 3x plus 9y. 3 minus 1 is what? 2 minus 2 e raised to 3x. 3 common. X plus 3y is required equation of curve. Question number 3. Find equation of curve passing through point. Find equation of curve passing through point 3 by root 2 comma root 2 having slope of tangent to curve at any point, having slope of tangent at any point xy is minus 4x upon 9y. Let equation of curve be y is equal to fx. Slope of tangent at any point x comma y is equal to dy by dx. So dy by dx is given to be minus 4x upon 9y. So 9y dy is equal to minus 4x dx. On integrating, we get 9 integral y dy minus 4 integral x dx plus c. So 9 times y square by 2 minus 4 times x square by plus c. Multiply over by 2 and bring 4x square on this side. So 4x square plus 9y square is equal to 2c. Equation 1. Since curve passes through point 3 by root 2 comma root 2. 3 by root 2. Therefore, 4 into square plus 9 into root 2 square to c. So 4 into 3, 9 by 2, 18 plus 18. Substituting the value of 2c in equation 1. Four x square plus is equation of required. It is an ellipse. Question number 4. The curve passes through point 0.02 the sum of coordinates of any point on the curve the sum of coordinate of any point on the curve exceeds the slope exceeds the slope of tangent to curve at that point by phi. At that point by phi. Find equation of curve. Let equation of curve According to problem, slope of tangent, the sum of coordinates of any point, x plus y. This is phi more than slope of tangent. So dy by dx is what? Minus y. Is equal to x minus phi. Is linear differential equation in x. Here p is what? And q is x minus phi. Integrating factor is a raised to integral p dx. Multiplying equation 1 by so e raised to minus x dy by dx. X minus phi the left hand side is what? D by dx of e raised to by definition of phi minus x e raised to minus x minus minus plus again integral e raised to minus x got e raised to minus x upon minus 1 plus c divided by e raised to minus x. So y will be what? Phi minus x minus 1 plus c raised to minus x plus y 4 plus c raised to x, not minus x. Now we need to find out c. This is writing question number 2. Curve passes through zero 2. Therefore, substituting c in equation 2, x plus y 4 minus 2 is equation of required curve. If slope of tangent to curve and each point at any point is sum of abscissa and product of abscissa and ordinate. Sum of abscissa and product of abscissa and ordinate. Of the point if curve passes through point 0, 1, find equation of curve. Let equation of curve be y is equal to fx. According to problem, dy by dx is what? X plus xy. X common 1 plus y. Dy upon 1 plus y on integrating we get integral dy upon the log x square by 2 plus c. Since curve passes through 0, 1, therefore log 2 is equal to 0 plus c. So c is log 2. Substituting c in equation 1, log 1 plus y x square by 2 plus log 2 minus log 2 is what? 1 plus y upon 2, 1 plus y e raised to x square by 2 is equation of required. Thank you very much. Lead from the heart, not the head. जो भी लीड लेनी है वो दिल से लीजिए, ना कि दिमाग से. Thank you very much.